All right. The Movement Self-Design Lab. So, a little bit of information about movement. The vestibular system allows for your body to maintain balance and posture, and it is the most important part of movement, and it is the largest part of movement. Um, the cochlea is an organ found within our ears. It is connected to the semicircular canals, and it is where the vestibular sense comes from. Um, Right next to the cochlea are the ever important saccule and utricle. Um, Basically, here, let me show you a little bit here and here. Um, the saccule is a little bit cut off here, but yeah, it is this right here. The saccule and utricle to detect gravitational forces and linear acceleration. And these circular canals that are seen here, there are three of them, um, are filled with fluid and detect body horizontal and vertical movements. Um, and these are filled with hairs that act as receptors for the movement that your body does. And they send signals to the brain as they translate the endolymph movement, and the endolymph is the fluid within those canals. And the vestibulocochlear nerve sends the information from the cochlea and the canals to the cerebellum. So I chose movement, and my group chose movement because I personally pitched it, and because I did it in my first part, and I found it very intriguing and very interesting that, balance comes from the inside of your ear. What? Um, and what also intrigued me was a test and an experiment that I came across that basically said, if you close your eyes, you're not going to have proper balance. And I didn't really understand that. I thought that that was not correct. So that's why we chose movement. That's why I wanted to try and do movement. And thankfully my group mates were also very intrigued by it. So our hypothesis was if we stand on our dominant leg with our eyes open, then it will be less difficult than with our eyes closed. Um, so basically, standing on your one dominant leg with your eyes open will be less difficult than with your eyes closed. So yeah. And so our procedure was basically having the test subject stand on one leg and just balance with your eyes open. And then we would record how long they would stay up, and the max that we would record for was just 60 seconds. We attempted this three times, but unfortunately, my side of the class was not able to record three tests. And we did the same test, but this time with our eyes closed. And we wanted to do that again for three tests, but of course, my side could only do two. Um, Time was in the way of that. So, yeah, this is our 2 times SCM graph. Um, but basically, the results showed that and the champs did amazing with their eyes open. They literally all maxed their times out. And the Lakers did the same, except for the exceptions of Officer Jacobs. But basically, it was very interesting and very fun to watch. But the champs did not do so well with their eyes closed. They had an average of 31.62 seconds on their one leg with their eyes closed. And the Lakers were the same way. They ended with an average of 49.689 seconds with both eyes closed, which is very interesting. Um, and so basically, this is the 2 times SCM graph. Um, the first one here is empty because there was no standard deviation because all of the champs lasted 60 seconds. This is champs with eyes closed. Basically, they were more fluctuating. Some of them were able to go for the full 60. Some of them went for just 4 seconds. So yeah, and then us with the Lakers with the eyes open. We were pretty much 60, except for Officer Jacobs. Uh, and then we were all still very good with our eyes closed. But it did last. We did have a couple people that did not last 60 seconds. So that is why it is a little bit lower than the champs, because the champs had a couple more people. They had most of their people not last 60 seconds. So yeah. So the explanation that I came across, and this is something that I found when I was researching the test that people did, and I did not find it to be something I thought was real. We did expect this to happen because of the research we did, and when you close your eyes, the ability for your vestibulo-ocular reflex to work dampens. You see, your eyes cannot see where you are or what is happening around you, and when the muscles that make your eye move cannot work properly, then you are unable to balance. And the reasoning for this is because there's a nerve that connects both your vestibular system and your ocular, or basically your eyes. And so that is why they're both connected. Um, and so basically, when you close your eyes, your optic nerve also has the inability to send information to your brain about your surroundings and what's happening and all of that. And it is relatively easy to stand on one leg with your eyes open because you can see your surroundings and your reflexes are working. And your vestibulo-ocular reflex is working. So yeah, and so there were just a couple of errors that we had to consider. Basically, there weren't many because we were able to watch people do this, and it wasn't a very long test and experiment. So people touching tables in order to maintain balance, I saw it a couple times. Let it slide a couple times, but people opening their eyes to try and see for a second or squinting their eyes for the entire time. I don't know if this happened. Obviously people were making jokes. Oh, he's opening his eyes, stuff like that. And then I wonder what this last one's about, but basically jumping and hopping around continuously. Definitely did not happen at all. Kind of hard to believe that anybody would do that anyways, but yeah, basically I did that. If you couldn't understand what I'm saying. Basically, yeah, jumping and hopping around continuously um, really does not count. So yeah, these were the errors, and this was the test. It was super fun, and I know a lot of the classmates had fun doing this. So yeah, I was really really happy with the test and how it went because it was very cool. So yeah.